morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, we are going to discuss about what are the various case studies which are involved in ground improvement techniques. So, on which basis what we are understanding those properties of the design, what are the required properties for the construction work, what type of soil it is existing. So, what kind of modifications we will require. So, according to those kind of scenarios for Vibro Compaction port construction. So, at port construction, Vibro Compaction is our case study in this particular lecture. So, here in this particular lecture, what we understand is that in a time of port construction, what type of challenges we may get as a civil engineer in terms of geotechnical conditions, how we overcome. According to the challenges, what are the solutions are there, we will observe in this particular case study. In any case study, what we understand is at the end of the completion of that particular case study, what type of structure it is, as per where we are going to construct that particular construction work, at that particular site, what are the soil conditions, what are the groundwater table, what are the water conditions, what are the nearby structures, what type of area it is in terms of whether it is densely populated area, whether it is less populated area, whether they affected industrial effects, any roads, buildings, forest, what kind of environment it is. These are the adoptions we have to understand. Then we choose what kind of technique gives the better results or desired results for that particular scenario. So, in this case study, in this particular case study, what we understand, the expansion, Jawaharlal Nehru Port Trust, that expansion in Mumbai in India. So, this is the project. So, in this project, what are the challenges which we are going to face? What kind of remedies are available? In that, what gives the better results for getting the desired properties in so many various ways, in cost point of view, safety point of view, strength point of view, so many various point of views we are going to understand that particular thing. So what we require, it is public interest, the safety is the priority, and it is budget constraint. Even though safety is important, but cost-effective measures are, any cost-effective measures give the same result with same effectiveness. So these are all the things we are going to understand in any kind of construction project. So before construction of that project, we have to understand. This is the extension. We are going to expansion of the project. So it means it is existing one. How we are going to expand? In which perception the expansion is required. So, these are all the parameters. How the existing structure condition. These are all the parameters we have to understand for considering the properties. Once we understand from construction point of view, now we are aware about the what kind of requirements are available. Those in that which is suitable for getting the better results. These are all the things which we are going to understand in this particular case study. Not only this case study, any kind of case study, these are all the parameters we have to understand. So here, in this, the background, once we understand the project overview, it is India's largest container port. So which is located in Mumbai. So why it is in Mumbai? Because of the population and the access from other countries, whatever it may be, there is a strategic reason which is located in Mumbai. So with the rapid growth in merit time of the trade, the Jawaharlal Nehru Port Trust expansion project was initiated to increase the port's capacity. So this is the one of the overview. So because of the rapid growth, so we didn't expect that much growth. So that's why Now we required the expansion because of the rapid growth of that particular port. This expansion involves the construction of new berths, container terminals and other port infrastructure. Here also, what are the various elements involved in that port? What kind of expansion we required is also the parameter for understanding or for getting the right technology. Here we require in terms of new berths, container terminals and other port infrastructure. So it means it's overall complete expansion. In all aspects we are going to expand this. Not only few elements, some part of the port we are not going to expand, we are going to expand in all aspects of the port infrastructure point of view. In this, now we have to understand what are the nature, what kind of culture of soils, what kind of previous history of the Mumbai port. In that locality, what kind of any kind of tsunamis, earthquakes, what kind of structure, what kind of atmosphere, any cyclones, all these parameters, all few more are there. These are the examples. So we have to analyze the background of that particular area where we are going to expand the port, the area history in terms of these parameters. In this, given the nature of the coastal site, so we have to understand in terms of nature of the coastal site, which consists of loose sandy soils. So first we have to understand the nature of the site, which consists of loose and sandy soils. Ground improvement was necessary to ensure the stability and longevity of the structure being built. So this is the project overview. So what we required, what kind of atmosphere is there in terms of soil point of view. So what kind of improvement we required, these are the things we are understanding this project overview. In this, the expansion finally, this is loose and sandy soils, the type of ground improvement to ensure the stability and longevity. For complete expansion of the port in terms of new berths, container terminals and other port infrastructure. So these are the parameters we have to understand. In this, what are the geotechnical challenges? The first step, what we understand as a part of civil engineer, we have to understand what are the geotechnical challenges. The primary challenge at this JNPT site was the presence of loose, unconsolidated sandy soils with low density. Density is the one of the parameter, and type of soil is loose soil. Loose and sandy soil. Type of soil is loose soil, and the properties are, what kind of properties are density. And these soils pose what kind of results? The risks including what kind of risk we are getting, that is excessive settlement, and liquefaction potential because of the loose soil and heterogeneity of the soil. Heterogeneity of the soil. These are the parameters which we are going to understand in this type of soil. So here, these are the risks we are going to understand. These are the challenges what we are understand from this kind of soil. So these soils posed several risks including excessive settlement, liquefaction potential and heterogeneity of soil. So in this excessive settlement, because of the loose sands were prone to significant settlements because of the heavy loads. Why? Because in this any kind of rows, containers, heavy cranes for moving, exporting and importing material. So huge cranes and containers, shifting material. So other infrastructure we are using, they are all in heavy loads. So the ships and they carry heavy goods. So these required heavy cranes, heavy machinery and containers. Other port structure also, it comes under heavy loads. So it leads to the settlements because of the heavy loads. It leads to the settlement. In being it is comes under that Mumbai area and it is comes under earthquake zone because of these seismic zone and that too sandy soils. It is a risk of liquefaction at during of earthquake. Whenever because of the seismic wave, it is going to liquefy because of the silt and these loose soils. They are allowing these seismic waves. It is going to liquefy, which could lead to the catastrophic failure of the port structure. So it affects. And this heterogeneity of the soil, the varying composition and density of sandy soils across the site required a ground improvement technique that could be tailored to address these differences efficiently. So because of the varying composition, density of the sandy soil across the site required, the ground improvement could tailor to address these differences effectively. These are the major challenges what we consider, what we understand because of the loose sand soils for expansion of the port. These are the primary geotechnical challenges. In this, which type of technique we adopted, that is the Vibro Compaction technique. It is a ground improvement technique specially designed to densify the loose granular soil. So here it is for the densify loose granular soils. So the process involves in insertion of the vibro float, cavity formation and filling, grid pattern implementation, depth of treatment. These are the major steps involved in this. The one is insertion and next one is the filling, insertion after filling. Next, what kind of grid pattern we are choosing and depth. Till how much depth the treatment will done. These are the steps which are involved in the Vibro Compaction technique. So in this, the first one in insertion of the vibro float. So a vibro float, which is a vibrating probe, is inserted into the loose sandy soil. We are going to insert it. So the vibration generated by the probe reduces the friction between the soil particles, allowing them to rearrange into the denser configuration. So it reduces what kind of, because of the loose soils, the friction is more between the soil particles. So this vibration generated by the probe reduces the friction between the soil particles, allow them to rearrange into the denser configuration. So it is going to densify. After that, the next step is the filling. Cavity formation and filling is the next step in the process. So as vibro float vibrates and compacts the surrounding soil, so it is going to compact. Denser means it is going to compact the surrounding soil. It creates a cavity. It creates a cavity. So granular material, typically sand or gravel, is added to the cavity. The vibro float is then slowly withdrawn while continue to vibrating, compacting the newly added material and the surrounding soil. We are going to filling the granular material. Because of these vibro float vibrate and compact the surrounding soil, it creates cavity. So in granular material, typically whether it is sand or gravel is added to that cavity, the vibro float then slowly withdraw while continuing the vibrate, compacting the newly added material and the surrounding soil. The next step, the grid pattern implementation. This process is repeated in a predetermined grid pattern across this site. The spacing of vibro float insertions is based on the soil conditions. So in this grid pattern, how much spacing is between one to other, it depends upon the purely soil conditions and the required degree of compaction. So these are the things, how much spacing is between the vibro plate insertions. So the grid pattern ensures uniform densification of the soil over the large areas. So why? Because this kind of large areas, once we consider it is a large area, so same kind of soil densification is not there throughout the area. So we assures because of this grid pattern, then densification of the soil over the large areas is to be uniform. In this depth of treatment, how much depth it is required, this compaction technique at this particular case study, Jawaharlal Nehru Port Vibro Compaction was carried out up to 20 meters depending upon the thickness of the loose sandy layer. So how much this loose sandy layer is there, it depends upon that particular thickness of the sandy layer. The depth of treatment was crucial in ensuring that the entire problematic soil layer was adequately compacted. So once we using this vibro compaction, we are going to insertion, and after that, because of this insertion, we are getting some sort of cavity, we are filling, and we are also densified the surrounded angle, and according to the grid pattern based on the soil conditions, we are going to uniformity between the densification soil over the area, and how much depth we are going to, it depends upon how much the depth loose sandy soil is there. So for that, we are going to understand the vibro compaction technique and this process. Now, how we monitoring and quality control. So to assure the effectiveness of the vibro compaction process, rigorous monitoring and quality control measures were implemented. So on-site density tests are in situ density tests. So we are conducting. These tests were conducted before and after the compaction, before and after the vibro compaction process done. Vibro compaction technique. Before and after we are conducting these tests. So measure those properties. Those are density, like that we are measuring before and after, and confirm that the desired improvement had been achieved. And in shear wave velocity measurements, these measurements provided additional data on the soil's stiffness and resistance to the seismic activity. So these shear wave velocity, we are going to understand how much stiffness and resistance to seismic activity, helping to assess the reduction in liquefaction potential. And also the CPT, it is nothing but the cone penetration test also we are conducted. It is used to evaluate the soil's bearing capacity post compaction and to identify any areas where additional treatment might be necessary. Like that, we are going to monitoring and quality control done using some of the tests for understanding what we density point of view, it means properties, and also seismic activity, and any additional treatment is required or not, we are going to understand using these tests under the process as a process of monitoring and quality control. In this, outcomes and lessons learned, what kind of outcomes we are understanding in this? The soil improvement. Using this vibro compaction technique process at Jawaharlal Nehru Port Trust successfully increased the density. So that is the property, it is going to increase the density using this technique, and shear strength. This type of soil is loose and sandy soils is the type of soil, and these are the properties are going to modified. This is the type of soil modified using the vibro compaction technique. Vibro compaction is the ground improvement technique. So these are the things we are going to understand. So because this is the improvements what we understand, and also it reduces the settlement. So because of the densified soil exhibit significantly less settlement under loads, ensuring that the stability of heavy port infrastructure. So soil improvement in terms of density and shear strength, and also denser soil, it is the reduced the settlement. Liquefaction mitigation is also there. The increased density and shear strength of the soil. So because of increased density and shear strength of the soil, greatly reduced susceptibility to liquefaction during seismic events, thereby enhancing the safety and resilience of the port facilities. These are the outcomes what we understand using this technique for this kind of soil, loose and sandy soils. So these are the outcomes. In this, we may understand the challenges. The implement of Vibro Compaction at Jawaharlal Nehru Port Trust was not without its challenges. So that is uniform compaction across large areas. This is the challenge what we understand, and also the ground management. So once achieving uniform compaction over existing area of the port expansion, it's required meticulous planning and precise execution. So the variation in soil condition necessitate adjustments to the compaction process to ensure consistent results. In groundwater management, managing groundwater levels during compaction was critical. High groundwater level could reduce the effectiveness of vibrofloat by increasing soil saturation, leading to the potential instability. These dewatering techniques were employed to control groundwater and maintain the optimal condition for the compaction. So these are the challenges which we are going to overcome at the time of implementation of the Vibro Compaction at this particular case study. In these environmental considerations, different kind of environmental considerations which we are going to observe, those are, as per this particular case study, we use this technique, that is Vibro Compaction is considered as an environmental friendly ground improvement technique because it minimizes the need for important large quantities of fill material. So it's importing. It minimizes the need for importing large quantities of fill materials. This is the one of the environmental friendly task as a ground improvement technique when we use this Vibro Compaction. Here, however, this environmental friendly, in this parameter, several environmental concerns were also addressed due to this particular case study, Jawaharlal Nehru Port Trust Project, Mumbai. So here, that is the noise and vibration control. Here, Vibro Compaction is the technique we are choose for the getting the desired properties of the soil. Here, noise and Vibro Compaction, the operation of Vibro floats generates whenever we are doing as a process of Vibro float, when we are installing into the required desired depth, at the time it generates noise and ground vibrations also, which could potentially disturb nearby communities and marine life. So because the port is itself nearby marine and nearby communities. So where that particular port we are constructing, that particular areas. So that environmental concerns where we understand because of the marine life, it is nearby, it is sea. Port is nearby sea, at sea. So we are constructing port. That's why we understand the marine life also. So this comes in because of the environmental condition. Where we are doing that particular construction, those parameters are involved. So that's why we consider this marine life. So to mitigate these impacts, work was scheduled during off peak hours, and vibration monitoring was conducted to ensure compliance with environmental regulations. So we have to done along the regulations, obey the legality. Then we will get the environmental concerns and without disturbing all kind of environment, any kind of environment, and also without disturbing the marine life, the effective is less. So then we are able to use these kind of technique gives the environmental concern. And one more, this is the comes under noise and vibration control and dust control. Whenever we choose this vibro compaction, so this process whenever we are installing and what kind of, and we follow the process and we fill and up to the certain depth as per the soil conditions. In the process, the dust control is also one of the environmental concern which we have to understand. In this particular, whenever we are adding the granule material for reducing the cavitation, how we will get cavitation? Because of the induction of the, once we are introducing, we are inserting the vibro compaction with using the vibration into the desired depth. At that particular process, we got the cavitation. For reducing the cavitation, we are getting these kind of granule material we are adding for cavities. So at that granule material, whenever we are adding, that process may lead to the dust. So at that time, we are going to control the dust as an environmental concern. So the process of adding granule material to the cavities created by the vibrofluids had potentially to generate dust. So water sprays and dust separation measures were used to minimize the airborne particles and protect air quality. So because of the dust, we are getting the air pollution. So for we are reducing the air quality. So for that we have to take measures to minimize these air quality, and we protect the air quality and we reduce the effective. We are going to reduce the effect of the air quality because of the, based on this dust control. It is also one more environmental concern which we have to understand in this particular. And broader implications for ground improvement. The successful application of vibro compaction at Jawaharlal Nehru Port Trust, Mumbai highlights several important considerations for ground improvements in similar projects. The suitability for sandy soils, customization and flexibility, cost effectiveness. In this, the suitability of for sandy soils, vibro compaction is highly effective for improving loose granular soils, making it an ideal choice for coastal and port projects where such as soils are common. These kind of soils. And customization and flexibility. The techniques flexibility allows it to tailor to site-specific conditions. According to the site-specific conditions, ensure that even areas with variable soil particles can be effectively treated. In cost effectiveness, by reducing the need for imported fill and enhanced the soil's load bearing capacity, vibro compaction can be cost effective solution compared to the more invasive ground material methods like deep foundation or soil replacement. So when we choose these deep foundations or soil replacement, are in more environmental considerations is required. More environmental concerns and considerations are required, and also it required material, and choose the material is also important parameter and need more attention compared to vibro compaction. So in this deep foundation has required various design considerations, and also it is cost. It is more cost when compared to conducting the process of vibro compaction, and it required huge material, and also that particular material how it is works, and again we have to understand the seismic waves, all these parameters in different parameters. In this, These expanded and whatever the background it for these importance of the Jawaharlal Port Trust is not just a major port in India, it is the one of the most crucial hubs for international trade in this region. So handling that kind of important portion of India's this cargo, what kind of containerized cargo, JNPT's expansion was vital for accommodating large ships and increasing throughput. This expansion is a part of India's border strategy to enhance its maritime infrastructure, which is critical for supporting the country's economic growth. So these kind of projects need more attention in so many parameters. Safety, economical. It is a prestigious expansion project. So because of the international trade and also the huge every time it is huge because all tradings and international dealings and everything is there, so it huge effect in the country's economical growth. So it is important. So the safety and the sustainability of the project is very, very important. And what are the site conditions? What we understand before beginning the construction? What we understand, the comprehensive geotechnical investigations were carried out to understand the soil conditions. The site primarily consisted of the loose sandy soils with varying degrees of saturation. The presence of high groundwater levels. Because of these conditions, it is nearby sea. So it means the groundwater table is high, the water is available, and the groundwater levels are highly high groundwater table levels, and this adds more complexity, more challenges. This adds more challenges to the particular work. So because of these complexities, initial assessments indicate that without ground improvement, the risk of differential settlements, instability under load, and potential liquefaction during the seismic wave would be unexpectedly high. These are all high, but it is important in country's economical growth, and it is the major port and also the prestigious project. So for international trading is happening in that particular thing. So these are all the parameters we have to understand in this site condition. So for that purpose, first before going to the construction, before going to the expansion, we have done the comprehensive geotech conditions investigation and also understand in all soil conditions, primarily for these varying how we are going to even uniform settlement and what we have to do with the seismic events are happened. So these are all the things we have to understand in depth. Then only we are going to choose this Vibro Compaction technique. In this detailedly we understand these equipment and machinery what we used for this Vibro Compaction technique. In this Vibro float, it is the key equipment used in the Vibro Compaction, that is the Vibro float, which is essentially a large vibrating probe. So these Vibro float operates at frequencies that are specially tuned to the soil's natural frequencies, causing the soil particles to rearrange the denser state. So this Vibro float operates at frequencies that are specially tuned to the soil's natural frequencies, because it is going to cause the soil particles to rearrange into the denser state. For this operating principle, what we involved in this Vibro float is typically powered by the electric motors and is capable of generating vertical vibration that propagate through the soil. The vibrations reduce the interparticle friction in granular soils. It automatically reduces the interrelation between the friction between the particles. It leads to the densify the soil. So that allowing the particles to move closer together, thereby it increases the soil's density. It is densifying. In this ancillary equipment what we used, the cranes are reached to position and operate the vibro float, as well as pumps and compressors to manage the insertion and withdrawal of the vibro fluid. So at the time of insertion and withdrawing process, we are using these kind of pumps, compressors, and we are going to operate. In this, the sequence of operation, the first we are going to site preparation, insertion, and adding additional material, and also the grid pattern completion. These are all involved in this operation process. In this, the site preparation, before vibro compaction begins, the site is prepared by making out a grid pattern based on the soil conditions, and then it depends upon the design specifications. The grid pattern ensures uniform treatment of entire area. So, these before whenever we are begins this vibro compaction, the site is prepared by marking out of grid pattern. It purely depends upon the soil conditions and also the design specifications. The grid pattern ensures uniform treatment of the area. These are the things we have to understand at site preparation. This is the first step in the sequence of operation. In the next second step, what we do in the process, the next step, insertion of the vibro float. It is inserted, this vibro float is going to be inserted into the soil at the designated grid points. The designated grid points depends upon the design based on the design considerations and design specifications. And also the spacing between depends upon the soil conditions. It is driven into the ground either by its own weight or by the additional force from the ridge. It depends upon the soil condition, the type of the soil. So how it is going depends upon the based on the soil type of soil. The probe is typically inserted to the full depth to the loose soil layer. How much the soil layer is, we are going to identify using based on the test and that particular. So in this particular case study, Jawaharlal Nehru Port Trust, Mumbai was up to 20 meters. It is going to vary. It depends upon the how much depth, full depth the loose soil area is there. So till that depth we are going to insert this vibro float. So here that particular case, in this particular case study it is 20 meters. And the next process as a part of the vibro compaction technique, the next one is compaction and addition of granular material. As the vibro float vibrates, it compacts the surrounding soil. So, it vibrates, it compacts the surrounding soil. In many cases, additional granular material such as whether sand and gravel is added into the cavity created by the vibro float. Because of this insertion and the process, the cavitation is formed. The cavity is formed. So, whenever the cavity is going to created by the vibro float, so to fill the sand or gravel which is added into the cavity, the material filled with voids left by the displaced soil and is compacted and probe is gradually withdrawn. So, in many cases, the addition of granular material is required. Very few cases there is no need of this, that cavity won't form. In that scenario, we are not going to add, otherwise we have to add these things and it is going to compacted done in this particular stage. Now this grid pattern is completion. The process is repeated across the entire site. So based on the spacings, based on the whatever it thinks, the process is repeated across the entire site following the grid pattern. This grid pattern design is considered based on the design considerations under the soil conditions. How much uniformity is required? These are the parameters for this grid pattern. The spacing of grid point is critical and is determined by the required of degree of compaction and based on the characteristics of the soil. These are the sequence operations which are presented in this Vibro compaction. The site is going to prepare, you are going to insert the Vibro float. After that compaction is done, the same procedure is repeated throughout the area. So these are the sequence. Now the depth and intensity of the treatment. So how much depth? So same kind of depth, till same depth is not required entire area. So the variable depth, intensity of the compaction, we are understanding in those 2 points. In variable depths, the depth of treatment is adjusted based on the geotechnical characteristics of that particular site. In some areas, deeper compaction might be necessary to reach the required properties, while in other areas, shallow compaction may sufficient. It depends upon the how much area this loose or sandy soil is present. In this much area, till 10 meters may be the loose soil, here only 15 meters, like that, the variations may there. It depends upon the how much depth the loose and sandy soils are there. It is depends upon the thing. And intensity of the compaction. In this, the intensity of the compaction, that is nothing but the energy delivered to the soil, can also be varied. This is typically controlled by the adjusting the vibration frequency and the duration of treatment at each point. So how much energy is delivered to the soil is also depending upon the soil characteristics. And how we are monitoring, what kind of test we are conducting for these in detail. This cone penetration test, standard penetration test, shear wave velocity measurements. In cone penetration test, CPTs are performed both before and after compaction. Before compaction and after compaction. Before, what kind of resistance to penetrate, what is the density, and after that what is the density, we get the desired density or not. Here the CPTs are performed both before and after compaction to measure the soil resistance to penetrate, which directly correlates with its density and strength. These tests provide a continuous profile of soil resistance with depth, allowing engineers to assess improvement achieved by the Vibro compaction. In standard penetration tests are used to determine the relative density of granular soils. These tests involve driving a standard sampler into the soil using a hammer of known weight, and recording the number of blows required to achieve certain depth of the penetration. An increase in the number of blows after compaction indicates a denser soil structure. In shear wave velocity measurement, shear wave velocity is measure of the soil stiffness. By measuring the speed at which shear waves travel through the compacted soils, engineers can infer the soil shear strength and resistance to the seismic forces. These are the in situ testing which we are conducted. As a part of quality insurance, control charts, documentation and reporting is required. In these control charts are used to track the results on-site tests and to ensure that soil compaction meet the specified criteria or not. It means the desired property of the construction work. Properties of the port. Here in this particular, that is port, otherwise our project. If test results fall outside of acceptable ranges, additional compaction may require. And we have done the additional compaction. And next, the detailed records are kept for all compaction activities, including at which depth, how much duration, and incentives of vibro operators at each grid. These records are crucial for assuring accountability and further reference also. In this overall, enhanced the soil properties and liquefaction risk, reducing the liquefaction risks are the outcomes. So in this, as a part of enhanced soil properties, the vibro compaction significantly improved the density and shear strength of the loose sandy soils at Jawaharlal Nehru Port Trust. This resulted in a much more stable foundation, capable of supporting the heavy loads imposed by port infrastructure without excessive settlement. Mitigation of liquefaction by increasing the soil density. The risk of liquefaction during seismic events was greatly reduced. This was a critical outcome, given the port's location in a seismically active region. In this, the challenges: achieving uniformity, groundwater management, vibration control. So one of the main challenges were assuring uniform compaction across the large variable site. Differences in soil composition and water content require adjustments to the compaction process to achieve consistent results. As a part of groundwater management, the high groundwater table posed a significant challenge. So we have to use traditional dewatering techniques were employed to lower the groundwater level during compaction, ensuring that the soil remained unsaturated and stable. As a part of vibration control, the vibration generated by the vibrofloat could potentially affect nearby structures and marine life. Therefore, it was crucial to monitor and control the vibration levels to minimize and any adverse impacts. These are the challenges. As a part of environmental considerations, minimization to fill material, noise and vibration management, dust and air quality control, these are the things. So one of the environmental benefits of vibro compaction is that it reduces the need for importing large quantities to fill material as the existing soil is densified in place. This minimizes the environmental footprint of the process. Noise and vibration management. The noise and vibration generated during the vibro compaction were carefully managed to avoid disturbances to nearby communities and marine habitats. Work was scheduled during periods of low activity and barriers were used to contain noise. As a part of dust and air quality, these dust control measures such as water spraying were implemented to minimize the impact of air quality. These measures were particularly important in the dry season when dust generation could be significant. In broader implementation of our ground improvement applicability of the other projects, this vibro compaction is particularly well suited for projects involving loose granular soils such as those found in coastal and port areas. Its effectiveness in mitigating liquefaction makes it is available to linear regions prone to seismic activity. Land reclamation. This technique is also applicable in land reclamation projects where newly deposit soils are often loose and require densification before construction can be proceeded. For further developments in these vibro compaction technique, advances in vibro compaction technique, ongoing advancements in vibro float design and compaction technique are making it possible to achieve even greater depths and levels of soil improvement. These developments are expanded the range of projects where vibro compaction can be effectively applied. Integration with other techniques. In some cases, vibro compaction can be combined with other ground improvement techniques such as deep soil mixing or grouting to address complex soil conditions that may not be fully treatable with Vibro Compaction alone. These are the future developments which we may observe in Vibro Compaction technique. In the overall summary of this particular case study, the expansion of Jawaharlal Nehru Post Trust Mumbai case study offers a comprehensive understanding of Vibro Compaction process. Its application at this particular locality at Mumbai for this port, Jawaharlal Nehru Port Trust, and the various technical and environmental logistic considerations are involved. For UG Civil Engineering students, this case study provides valuable insights into the particular aspects of ground improvement techniques, the importance of site-specific analysis, and the need for careful planning and execution in large-scale infrastructure projects. Understand these concepts will equip students with the knowledge and skills necessary to address similar challenges in their further careers as a civil engineers. Thank you. We will see in our next class.
Like, share and subscribe. Hit the bell icon for more updates.